Hi everybody, welcome to our section 5.9 lecture video where we are going to be doing problem solving with equations that are containing decimals. So just like when we were solving equations that contain fractions, when you have equations that contain decimals, you've got two options. If you're good with operations with decimals, which I assume most of you guys are, especially since you have a calculator, just solve normally. But if you really would like to work out an equation that doesn't have decimals in it, what you do is you multiply both sides of your equation by a power of 10 to get rid of your decimals. Okay. So we're going to do a lot of examples today. I'll do a few, I'll let you guys try quite a few, and the more you guys practice these, the better you're going to get at these, but I think you guys can do them, okay? So the first one I have in example A is 0.03x equals 0.9. So I would probably solve this one normally. I think x is multiplied by 0.03, so the opposite of multiplication would be division. So I'm going to divide both sides by 0.03. And you remember with solving equations, whatever you do to one side, you've got to do to both sides so that they stay in balance. 0.03 divided by 0.03 is 1. So now I have 1x, which is just x. And then on the other side, I would have 0.9 divided by 0.03. And you're welcome to use your 4-function calculator for that one. And 0.9 divided by 0.03 would be 30. Okay. If you were using the other method, if you really don't like decimals, I'll show you what that looks like. For this first one, what you would do, because there are 2 decimal places, you'd multiply by 100 on each side. And so if you multiply by 100 on the left side, you'd have 3x. If you multiply by 100 on the right side, you'd have 90. It's kind of moving this decimal place over twice, that decimal place over twice. And then you would still divide by 3 on both sides instead of dividing by 0.03, and you still end up with 30 as your answer. But that's what it would look like if you multiply by a power of 10. Okay. But for the rest of these, I think I'm going to solve them normally, okay? In part B, I've got x plus 3.6 equals negative 12.84. So I'm trying to get x by itself. The thing on the same side of it is the plus 3.6. The opposite of adding is subtracting, so that's what I'm going to do. I'm going to subtract 3.6 from the left side, and I'm going to do the exact same thing on the right side so that everything stays in balance. Positive 3.6 minus 3.6 is 0. x0 is just x. On the right side, negative 12.84 minus 3.6, so that's really a negative number plus another negative number. I should be adding those values together and getting a bigger negative number as an answer. So in a 4-function calculator, you would do 12.84 plus 3.6, and you would get 16.44. Then your answer is going to be negative, because a negative plus a negative gives you a bigger negative answer. Alright, let's do another one. In part C, I have 5x plus 3.6 is 8x plus 12.84. The first thing I like to do is get my variables together. So you could either subtract 5x from both sides to get all the x's on the right side, or you could subtract 8x from both sides to get them both on the left side. Doesn't really matter. How about I subtract 8x? We'll get them on the left side. So the reason I'm subtracting is because this is positive, and a positive 8x minus 8x would be none, be 0. There wouldn't be any x's left on the right side. All of them would be on the left side. 5x minus 8x is negative 3x. And then I still have a plus 3.6. still have an equal sign, and on the other side I still have a 12.84. Then I'm trying to get my x by itself. So I need to get rid of that -3, and I need to get rid of the 3.6. Technically you could get rid of either one, but it's a little bit easier to get rid of addition or subtraction first, before you go dividing everything by -3. So it is added, so the opposite of addition is subtraction. I'm going to subtract 3.6 from both sides. 3.6 minus 3.6 is 0, so we're just left with a -3x on the left side. 12.84 minus 3.6 would be 9.24. And then I need to get rid of the -3. The -3 is multiplied by the x. Opposite of multiplying is dividing, so I'm going to divide by -3 on the left side and on the right side. -3 divided by -3 is 1, so now I've got 1x. 9.24 divided by -3 is -3.08, and I'm done. Okay, once you get a variable equal to a number, that's what you're looking for in your answer, okay? Let's see, part D. We got x equals 0.5x plus 3.8. If you see a regular x like this, and you don't know what the coefficient is in front, it is a 1. It's like a xylophone is the same thing as having one xylophone. So if it helps to put a 1 here, just so you know what that number is, go for it. Then from here, I would probably try to get my x's together again. Since there's so much else going on the right side, I would probably move the x to the left. So it is added, so the opposite of adding is subtracting. I'm going to subtract 0.5x from both sides. 0.5x minus 0.5x is 0. 0 plus 3.8 is 3.8. 1x minus 0.5x, so I would do 1 minus 0.5, which is 0.5x. Okay. Then I need to get rid of the 0.5. It's multiplied by the x. The opposite of multiplying is dividing. So I'm going to divide both sides by 0.5. 0.5 divided by 0.5 is 1. So now I've got 1x. On the left side, I have 3.8 divided by 0.5, which is 7.6 on the right side. So x equals 7.6. Okay. Let's see, part E. I have 6.22 minus 5x equals 3, and then there's a parentheses, x plus 2.9. So that means that 3 is getting multiplied by the x and the plus 2.9. So the first thing I'm going to do is distribute. So I'm going to do 3 times x, and I'm going to do 3 times 2.9. So 3 times x is 3x. 3 times 2.9 is 8.7. I still have a 6.22 minus 5x on the left side. Then I've got x's in 2 different locations again. It doesn't matter which way you go, but you probably should get them together. So how about we deal with this one? I have a minus 5x here. The opposite of subtracting is adding. So I'm going to add 5x to both sides. Negative 5x plus 5x is 0. So now I've got 6.22 plus 0, which is just 6.22. I have 3x plus 5x, which is 8x, and I still have a plus 8.7. Okay. I want to get x by itself, so I need to get rid of the 8 and the 8.7. Which one's easier to get rid of first? Probably that 8.7, so it's added. So the opposite of adding would be subtracting. So I'm going to subtract 8.77 from both sides. 8.7 subtracting 8.7 is 0. We're just left with 8x on the right side. 8.22 minus 8.7 is negative 2.48 on the left side. Then I want to get rid of the 8. Well, it's multiplied. 8 times x is 8x, so the opposite of multiplication would be division. I'm going to divide by 8 on both sides. Negative 2.48 divided by 8 is negative 0.31. So I'm going to have negative 0.31 equals 8 divided by 8 is 1, so that would be 1x. There's my answer. Are you guys about ready to try one? Great. I'm going to let you guys have part F. So F has 0.7x plus 13.8 equals x minus 2.16. Pause your video. Go ahead and try this one, and I'll work it out here in 3, 2, 1. Alright, you should get as an answer x equals 53.2. So what I would do on this one, I would probably subtract 0.7x from both sides and get 13.8 equals 0.3x minus 2.16. I'd probably add 2.16 to both sides from here, which would give me 15.96 equals 0.3x, and then divide both sides by 0.3, which gives me my answer of 53.2. Okay? Let's try some more. The next one is 200x minus 0.67 equals 100x plus 0.81. Go ahead and try that one. So again, pause your video, work this one out, and I'm going to show you the answer here in 3, 2, 1. For your answer in part G, you should get x equals 0.0148. So what I would do on this one, I would subtract 100x from both sides. Then you would have 100x minus 0.67 equals 0.81. Then I would add 0.67 to both sides. So then I have 100x equals 1.48. And then divide both sides by 100, which would give you x equals 0.0148 as an answer. Okay? Let's see, part H. We got 1.5x plus 2 equals 1.2x plus 10 plus 2.2. I'll let you guys try another one, okay? There's a little bit of simplifying you can do before you really start your solving. So give this one a try, pause your video, and I'll show you guys the answer in 3, 2, 1. You should get x equals 34 on this one. So I would probably add the 10 and the 2.2 first. So you'll have 1.5x plus 2 equals 1.2x plus 12.2. Then I would get my x's together. I would subtract 1.2x from both sides, which would give me 0.3x plus 2 equals 12.2. Then I would get my x by itself by subtracting 2 from both sides. So then I would have 0.3x equals 10.2. And last thing I would just divide both sides by 0.3. And that's where x equals 30 comes from. Alright, we've got 2 more left, I and J. I'm going to let you guys try those last 2. It's a terrible looking star. So I is negative 0.6x plus 0.1x plus 0.81 equals 0.4x minus 0.54. See if you can solve for x. In part J, you've got 4, then a parenthesis, 3x minus 1.6, and then minus 4x equals 5x minus 5.4 minus 1. There's a lot of simplifying you can do with these. So work both of those out. I'm going to show you the answers in 3, 2, 1. In part I, you should be getting that x equals 1.5. In part J, you should get that x equals 0. Okay, so the work for this one, I'm just going to show you my other page here. Them already worked out. In part I would combine like terms first. To simplify, that would be negative 0.5x plus 0.81 equals 0.4x minus 0.54. Then what I would do is add 0.5x to both sides to get my x's together. And then you can also go ahead and add 0.54 to both sides to get all the numbers together. So you're going to end up with 1.35 equals 0.9x. Then divide both sides by 0.9, and that's where x equals 1.5. In part J, I would distribute the 4 first. So then that would give 12x minus 6.4, and then you would still have a minus 4x equals 5x minus 5.4 minus 1. And then there's a lot of like terms to combine, so 12x minus 4x would be 8x. We'll still have a minus 6.4 on that side. On the right side, I would combine negative 5.4 minus 1, which is negative 6.4, and you still have a 5x over there. So that would be 5x minus 6.4. Then to get all the x's together, I just realized I messed up on that one. You should be subtracting 5x from both sides. So subtract 5x, and you're going to end up with 3x. So that's going to make these a little bit different, okay? And then to get the numbers together, I would add 6.4 to both sides. So 6.4 plus 6.4 would be 0. So you'll have 3x equals 0. Divide both sides by 3, so that means that x would be 0. All right, last one today is a word problem. Many international calling cards add a connection fee to the cost of each card. The card that Maria used to call her sister's cell phone in Mexico charges $0.084 per minute, plus a $1.25 connection fee for each call. The cost of the call that Maria made today to her sister was $5.03. How many minutes did the call last? All right, so I see a lot of numbers here that could help us make an equation. So the card that Maria used to call her sister's cell phone in Mexico charges $0.84 per minute plus a $1.25 connection fee for each call. So the total cost for a call would be $0.084, and that's dollars per minute. So the amount of money that she's spending is at $0.084 times the number of minutes that her call lasts, plus, so we're adding a $1.25 connection fee for each call. The total cost of her call today was $5.03. So I'm going to have 5.03 equal to 0.084 times, I just used m for minutes, plus 1.25. So if I want to know how many minutes the call lasts, I just need to solve for m. To solve for m, let's see, I'll subtract 1.25 from each side. So 5.03 minus 1.25 would be 3.78 equal to 0.084 m. And then to get rid of that 0.084, it's multiplied. So I'm going to divide by 0.084 on both sides. So I'll have m equal to, then in the calculator you can just do 3.78 divided by 0.084, and you'll get 45. So m equals 45 means that it was a 45-minute long phone conversation. And that's it. So with these, if you noticed, I always made my equation first, substituted what I knew, and then I can solve. And I made sure that that thing that I solved for actually answered the question. So I wanted to solve for m because that was the number of minutes for the call and answers the question. Okay, hope this helps you guys, and hope you guys have a wonderful week.